Hello everyone. So previously we had successfully designed a coupon or discount manager system, right? So today what we'll be doing will be we are asked to design an auction system, or we can just call this one as online bidding system as well. Yeah. So see here, we are asked to design a simple in-memory auction system where users can create auctions. Yeah, where users should be able to create auctions, place bids while the auction is active. We have users should be able to place the bids while the auction is active and automatically determine the winner, right, when the auction ends. Basically the system must support concurrent bidding as well as this one as well safely, and maintain complete bid history. The system must support concurrent bidding safely and maintain the complete bid history, all without using any external database, right? So as we are just solving the problem, we are asked to go with a single file CLI demo, right? So we don't have to worry about the external database. So this is fine. We can discuss if we extend this one in the future, what's the database that we can make use of? We can just go with the SQL, this one, no SQL database. So what will be the pros and cons, other stuff that we can do. But for now, let's go with a single file CLI demo without any external database, right? So based on the question, let's collect the functional and non-functional requirements in detail. Yep. So first thing here would be the functional requirements, right? So let's first let's collect the functional requirement. See here, users can create auctions with a start price and the time window. With the start price and time window, just we have to um, take care of this. Yep. The second one, users can place bids while the auction is active. Yeah, users should be able to place the bids, right, while the auction is active. So this is the second requirement. The third one, system always tracks the highest bid. So system should always track the highest bid. This we have to take care of. So this is very important. The fourth one, auction ends automatically determining the winner, right? Auction ends automatically determining the winner. So this is very important as well, right? The fifth and the final one here, users can view auction details. Users should be able to view the auction details and bid history as well. We have to store the bid history, right? So let's move on with the non-functional requirements. These are some of the functional requirements. Yeah, 5 functional requirements. And let's move on with the non-functional requirements here. Simple in-memory data storage. So uh, user we have to go with a simple in-memory data storage here. We don't have to worry about the external database, right? So the second one, we are asked to go thread safe, meaning thread safe operation, sorry. So we have to go with the, or we have to deal with the thread safe operations just to avoid the race conditions while bidding, right? Just to avoid race conditions while bidding actually. So this is fine, I believe. Yep. Avoid race conditions while bidding. For that, we have to go with the thread safe operations. Yep. So third one, low latency for the read operations. Low latency for read operations. The final one, clean modular design for the future extensibility. Clean modular design for the future extensibility. So this one also we have to take care of. These are some of the non-functional requirements. So based on the functional and the non-functional requirements, I have went with the algorithm choice and the design pattern choice. Let's discuss the algorithm choice and the design pattern choice, right? So first, for the auction winner, let's keep the max heap approach conceptually, right? So for the simplicity, we will be making use of or yeah, for the simplicity use, let's run the max tracking, right? So we'll be going with big of 1 per update. Basically, we'll be making use of max heap approach conceptually here. Just keep this in mind, right? So the second one, time handling, right? So we have to deal with the time handling as well. So we will be going with a basic timestamp here, or primary timestamp comparison using Python's time module. So we'll be making use of the Python's time module for the primary timestamp comparison. The third one here, bidding. Bidding in the sense atomic update will be making use of the algo here, atomic update operations using logs. So this is simple, man. Yeah, mainly the approach of the algo will be going with this maximum heap approach or maximum priority queue approach conceptually, right? For the time handling, we'll be going with a primary timestamp comparison using Python's time module. Third one, for the bidding, we'll be going with the atomic update operations using log. So this is fine, I believe. So next, let's move on with the design pattern choice. Yeah, let's move on with the design pattern choice. The first one is observer pattern, right? So we'll be making use of the observer pattern conceptually. So see, let me tell you one thing here. So conceptual in the sense, actually, bidders subscribe to the auction updates, right? So this will be simplified print notifications actually in simple terms, yeah. So bidders subscribe to the auction sorry, simplified print notifications, right, in simple terms. So for that, we'll be making use of the observer pattern conceptually, right? So mainly we'll be making use of the singleton here, singleton, as we are going with the in-memory auction manager, right? So the third one here, so mainly we will be making use of the strategy pattern as well for the highest bid strategy, right? And we can just make use of the strategy pattern if you want to extend for the winner selection tools as well in the future. So it's better to go with a strategy pattern now itself for the currently highest bid strategy, right? For current highest bid strategy, sorry. So mainly we'll be going with the observer pattern conceptually because bidders subscribe to auction updates. Second one will be going with a singleton for the in-memory auction manager, and we'll be going with the strategy pattern. So for the currently highest bid, for the current highest bid strategy, right? And it can be extendable for the winner selection rules in the future as well, right? So these are the design patterns that we'll be making use of. Yep. So this is clear, I believe. Next, let's move on with the main part, concurrency and the data model, right? So based on the concurrency data model itself, we'll be designing the UML diagram, right? So along with certain discussions that we have made. So we'll be going with this one. Based on the data models, we'll be going with different parameters that we need to make use of and other stuff, right? So based on the discussions, we'll be going with certain classes, main classes, and the methods that we'll be making use of, right? What sort of logic that we have to implement within the methods, that those things. Yep. So now let's discuss the concurrency and the data model first. So concurrency part, when two users bid at the same time, so we will be making use of the threading.log because we have to maintain the concurrency here, right? So when two users bid at the same time, actually, when two users bid at the same time, we'll be making use of threading.log to ensure the highest bid updates safely, to ensure highest bid updates safely, right? So then auction ending logic uses safe read or write locking. This you will see when we write the code. Yep. So the same thing will be implementing in the form of code. Yep. So this is fine. Next, let's move on with the data model part. Yeah. So let's move on with the data model part. So auction consists of these parameters. One is ID. The second one is item name. The third one is start price. The fourth one is highest bid. The fifth one is highest bidder. The sixth one start time. Seventh one end time, and eighth one the bid history, right? So these 8 parameters that we will be making use of within the auction class. Just remember this one. Yeah. So the next one is auction manager, right? So what does the auction manager do here? Auction manager class, basically it stores all the auctions in the dictionary. It stores all the auctions in the dictionary. Yep. This is fine, I believe. Next, it provides um, create, start, end, as well as the bid operations. It provides create, start, end, as well as the bid operations based on the data model and other stuff that we have discussed about the concurrence, whether it may be concurrency, algo choice, and the design patterns. I have designed an UML diagram. Let's move on with the UML diagram part, right? So this is the main part. So yeah, so first thing, this is the auction, right? So auction, this one second. So yeah, we'll be going with the auction class actually as discussed. So it consists of the ID, item name, start price, highest bid, highest bidder, start time, end time, as well as the bid history, right? So we'll be going with two methods, namely place bid method as well as the two, sorry, mm, methods actually. One is place bid and another one is active method, right? So these are the parameters actually that we'll be considering, and we'll be going with the two methods, namely place bid as well as the is active. And let's come to the main thing, auction manager, right? Auction manager, right? So here, basically we'll be going with the parameter auctions, which is of the type dict, and we'll be making use of 4 parameters. We'll be making use of 4 parameters, sorry, 4 methods actually, not the parameters. Namely, one is create auction, place bid, third one is end auction, and fourth one is get auction, right? So these are the 4 methods that we'll be making use of, and this one parameter that we'll be making use of within the auction manager, nothing but auctions, which is of the type dict actually, which is of the type dict. So this is it for the UML diagram. Just pause the video and have a look into it, right? So this is fine. uh yes, these both are interlinked, right? So these both classes are interlinked actually. So these are the parameters that we'll be making use of within the auction class, and two methods will be going with that. One is place bid and another one is active. So we'll be going with the auction manager class as well, which consists of the auctions, which is of the type dict, and four methods, namely create auction, place bid, end auction, and get auction method. Yeah, so this is fine, I believe. Next, what we'll be doing here. So will be let's do one thing. Yeah, just pause the video and have a look into it. Yeah, just pause the video and have a look into it. Yep, so this is fine, I believe. Yeah, so based on the data model and other stuff, whether it may be concurrency, algo choice, and the design patterns. So we will be going with the three design patterns as discussed earlier: singleton, observer pattern, as well as the strategy, I believe. Yep. So let's do one thing. Mm, yep. So these are the classes, parameters, and the methods that we'll be making use of. So yeah, it's complete good time to write the code. Let's start writing the code actually. So let's start writing the code here. The first thing, we'll be making use of the time module as well as the threading module, right? So I'll just go with time here. This is fine. Also, let me import threading as well. So I'll just give here threading. So this is fine. Next, what we'll be doing, let's go with the auction class as per the UML diagram, right? So I'll just go with class auction. Yep, so this is fine. So within the auction class, first thing, let me go with the initialization part, or the this one, what do we call constructor part, right? So along with the this one self, I need certain this one parameters actually. One, I'll be going with the auction ID here. This is required, and let me go with the item name, the second parameter. So this is also required. The third one is start price actually. This is also required, and the fourth one is duration seconds, right? I'll just go with the duration seconds, right? So this is fine. Yep. So within the initialization part, sorry, 1 second. Let me delete this one. Colon is enough. Yeah. So within the initialization part or the constructor part, let's initialize certain things here. We have to store the unique auction ID. So I'll just go with your ID. Yeah, let me initialize this one with a auction ID. Yep, so this is fine. Next, we have to go with the item that is being sold in the auction, right? So let's initialize that one as well. Let me go with the item name here. So let me initialize this one to the item name. The third one, we have to go with the highest bid that begins actually, yeah, that begins equal to the start price, right? So let me go with the highest bid actually here. I'll just go with highest bid uh, that is equal to, let me go with the start price actually. This is fine. The next one, we have to track which user currently leads the auction, right? I'll just go with self dot, let me go with the highest bidder actually, right? Let me go with the highest bidder. So let me do one thing. Highest bid we have considered, we are going with the highest bidder, right? So let me initially set this one to the none. This is fine. Next, we have to go with the time with when act, or this one, sorry, auction starts actually. Basically or primarily, we have to consider current timestamp in simple terms. I'll just go with this one, start time. Let me go with the start time here. Let me initialize this one to time dot time. So this is fine. The next one, we have to go with the auction end time as well. That is equivalent to the start time plus duration in seconds. So I'll just go with end time, that is equivalent to start time. Yeah, this one, start time plus duration seconds actually. Yep. So this is also fine. Yep. Next, let's do one thing. Let's go with a list to store all the historical bids with the user and amount, right? So I'll just go with here bid history. Let me go with a bid history here, and let me initialize this one with a empty list actually. Next, let's go with a lock which ensures thread safe bidding when multiple users bid at the same time. We have discussed this one earlier, right? I'll just go with a lock, and let me initialize this one, or let me assign this one to the threading dot lock. So not the thread actually, it's threading. Yep. So this one, yeah. Mm, Now we are done with the initialization part. Let's move on with the main methods actually within the auction. we will be going with different methods, right? So first two methods, if you remember, right? So one is active and the second one is place bid. These two methods we'll be using. So you can just rewind the video and you can just go to the part where we discuss the UML diagram. Within that, we have mentioned, so I have mentioned two methods. One is active and place bid. These two methods we will be making use of, right, within the auction class. The first thing here would be this one is active, right? I'll just go with the is active method self. So within the is active method, we have to return true if the current time is still before end time, right? I'll just go with return here. Return is fine. Let me go with time dot time. Yeah, which is less than end time. So let me go with end time here. So this is fine. Next method, let me go with a place bid method. Yeah, I'll just go with a place bid method. So this time, let me go with two parameters. One is user and another one is amount actually. Yeah. So within the place bid method, the first thing, we have to acquire the thread lock to prevent race condition. So I'll just go with lock actually. So within this, what we will be doing, the first step, if the auction has already ended, so no bids are allowed at that particular time, right? So let's write the simple if condition for that. If not, let me go with the is active here. Yep. So within the if condition, what happened here? Yeah. Within the if condition, let's return. I'll just give something within the string actually. Let's give auction already ended, right? Message auction already ended. Yep. So this is fine, I believe. Next, what we will be doing. So we have to reject the bids lower than or equal to the current highest bid. So let's go with a simple, one more simple if condition here. If amount less than or equal to this one, highest bid actually. Yeah, this one, then what we have to do, let me return here. So let me return bid too low, right? I'll just go with bid too low, right? So this is fine. Yep, let me come out of this one entirely. So we have to update the highest bid, right? So I'll just go with highest bid. This has to show highest bid. Let me assign this one to the amount. We have to update the highest bid, right? Also, along with updating the highest bid, we have to update the highest bidder as well if found, right? So again, let me go with highest bidder here, in this case this one, and let me assign this one to the user, right? So this is fine, I believe. Next, we have to store the bid information in the bid history. That one we have to do. I'll just go with here, mm, bid history. One second. Yeah, bid history. Let's append the user amount and time to the bid history, right? So this is simple, man. So let's do one thing. I'll just pass the user here. Along with the user, let me pass the amount as well. Along with the amount, let me go with here dot time. So this is fine. Yeah, the next thing we have to do here is we have to confirm the bid placement to the user, right? I'll just return here. So this one, let me make use of the string interpolation here. Bid accepted. Mm, let's let me pass the user here. This is fine. Along with the amount actually. Let me pass amount here, right? So this is fine, I believe. Easy, easy peasy. So we are done with this particular method, right? So next, let's do one thing. So we are done with this class, auction class actually. Now let's go with the main class, nothing but this one, auction manager, right? So this is singleton. Auction manager uses singleton pattern. We have discussed this one. Yeah. So let's go with the main class, nothing but the auction manager class, right? I'll just go with the auction manager here. So within the auction manager class, first thing, we have to hold the single instance. So I'll just go with instance here. Sorry, not the built-ins actually, instance it is. Let me go with instance. So let me assign this one to initially none. Yep, so this is fine. Next, let's go with a new method actually, right? So I'll just go with new actually, this one of class. So what we'll be doing within the new, we have to create the instance exactly once, right? As we are going with a singleton. Let me write the simple if condition here. Class actually instance. Wait, this doesn't show up at the first place. This is fine. Instance is none actually Then what we will do within the if condition, so I'll just go with here instance. Yep. Let me assign this one to the super. Assign this one to the super of, let me pass the auction manager here, class auction manager. So along with the auction manager, let me call class here. So this is fine. Again, let me go with new, right? So we are going with a new actually. This is fine. I have to pass the class or else I'll be getting the error. Yep. So this is fine. Next, we will be considering dictionary for all the auctions. This we had discussed earlier, right? I'll just go with a class dot here. Let me go with the instance. Yep. Instance dot auctions. Yep. Instance dot auctions. So let me set this one to the dictionary. Yep. The next one, let me return something here. I'll just go with a return instance. So this is fine. Yeah. Next, we are done with the new method actually. Yep. So basically, or primarily, it creates the instance only once. And one more thing to remember here is we use dictionary for all the auctions, right? So these two things we have to keep in mind when it comes to the new method. First, and one more thing, within the auction, this one manager class, actually, we went with the four methods, right? So if you rewind the video and get into the part where we discuss the UML diagram, actually, you can see there I mentioned we'll be going with the four methods, right? So namely create auction, get auction, place bid, as well as the end auction. These four methods actually. Let's write the same. Let's write the logic for the same, right? Four methods actually. First, let's start with the create auction method. Yep, I'll just go with def here. First one, let me go with create auction. Yeah, so this is fine. Within the create auction, along with the self, I need certain parameters here. So namely auction ID, item, start price, duration seconds. These four parameters I need. I'll just go with auction ID here, followed by item, followed by start price actually, and the final one duration seconds. Yeah, duration seconds. Yep. So within the create auction method, we have to create a new auction object here, right? I'll just assign the auction to the auction here, and let me pass the parameters here. The first thing I have to pass here is auction ID. Let me pass this one over here. Next one, I have to pass the item. Let me pass this one over here. The next one, we have to go with the start price. I'll just copy this one and let me paste it over here. Let me pass it over here. The final one is duration seconds. Let me copy this one and let me paste it over here. Right, so this is fine. Next, what we have to do, we have to add the auction to the dictionary using ID as key, right? I'll just go with here auctions. This has to show create auction. It is showing. Uh, Anyways, I'll just type this one auctions actually. Auctions of auction ID. Yep. So let me assign this one to the auction. This has to show at least. Yeah, this is fine. Yep. Now, what we'll be doing, we have to return the created auction for reference, right? I'll just return here auction. Yep. Let me return the auction. So this is it for the create auction method. Very simple one. Yeah. Next, let's move on with the second method. So this is going to be a really simple one. Getting the action, getting the auction. Sorry. So let's go with a get auction method here. I'll just go with def here. Get auction. Yeah. Just give me a second here. So I need one parameter, nothing but auction ID. Based on the auction ID itself, we'll be getting the auction, right? So first, let's do one thing. Let's fetch the auction, this one by ID, and let's return none if it is not found. Okay? I'll just return here auctions. So this is file. Sorry, this is fine. Let me go with auction ID. Let me pass the auction ID here. Right, so we are done with the get auction method. Next, let's move on with the third method named place bid actually. Yeah, I'll just go with the third method named place bid. Yeah, so within the place bid method, so I need certain parameters, namely auction ID, user, and amount. Three parameters. Yep, so I'll just go with auction ID. So this is fine. The second one is user, and third one is this one amount actually. So this is fine. Within the place bid method, what we'll be doing, we have to fetch the auction object first. So I'll just give here auction equals. I'll just go with get auction, right? So let me call the get auction here. This has to show, yeah, get auction of. Let me pass the auction ID. Yep. So this is fine. This is fine. The next one, we have to check if the auction exists or not, right? So I'll just go with the simple if condition here. If not auction, then what we will do? We have to return auction not found. I'll just return here auction not found actually. Yeah, auction not found. So this is fine. The next part would be we have to delegate bidding to the auction instance, right? I'll just return here. Let me return this one AUC, nothing but the auction dot place bid. So I'll just go with the this one. What do we call place bid, right? So let me go with place bid here. Let me pass user along with the amount. Yeah, this is fine, I believe. Yep, so this is it for the place bid method. Very simple one. Yeah, we are done with three methods actually. We are left with only one method, namely end auction, right? So let me give here def end auction, right? So what are the parameters that we need? Only one parameter along with the self, nothing but auction ID. So I'll just go with auction ID. Yep. So within the end auction method, first we have to fetch the auction, right? So I'll just uh, make use of the variable AUC. I'll just go with again get auction. Yeah, similar to the previous method. We did the same thing, right? So I'll just pass the auction ID here. So this is fine. The next step, so we have to validate the existence. So if not AUC is the variable name that we have used, not auction, then we have to return something. I'll just return something within the what do we call string actually. I'll just give something like auction not found. Yeah, that's relevant here actually. Yep, I'll just give auction not found. So this is fine. The next thing would be if no highest bidder exists, then we have to return something. Again, I'll just return something within the string actually. Just write the if condition here. If auction dot, let me give the highest bidder. This has to show no. So let me type this one entirely. Highest bidder is none actually. This has to show. Yep, is none. Then let me return something within the strings message actually. Yeah, in simple terms, I'll just go with no bids placed. Yeah, so I'll just give your auction ended with no winner actually, no winner. So this is fine. The final one here would be we have to return the winner details. Yeah, I'll just go with the return here. String interpolation again, f followed by winner. Here, this is fine. Yep. So let me pass certain things here. You see auction dot highest bidder. So this one I'll just give highest bidder. Right. So yeah, this is fine with with this one bid. This one, let me pass something within the flower brackets here as we are going with the string interpolation. Highest bidder is fine. Let me pass highest bid. So this will be this is has to show actually this is so. Anyways, this is fine, man. So we are done with this part actually. We are done with the coding part. Yep. So we have went with the four methods as per the UML diagram. We have added the logic. So I have explained you this one step by step. I think I don't have to explain this one again, right? Yep. The design pattern, whatever the code that we have written, the different methods we have used, right? The different parameters that we have used, data modeling, and this one, and the other stuff. This one how many methods that we have used in the auction and how many methods that we have used in the auction manager class and what the logic that we have added, everything we have discussed, right? Everything we have discussed, and we have discussed the coding part step by step. Now usually I take the demo part or the this one example usage from the Google. Yeah, just let me do that. Just give me a second here. So yeah, I'll just come here and let me paste it over here. right? So I'll just come here. Let me do one thing. I'll just copy the entire file name here. So let's discuss the output. Now we have successfully written the code. I have pasted this one demo usage as well. So why this is showing error here? So I think I have given small m actually. I do that mistake every time. Option manager. Yeah. Let me make this one capital M so that the error will be gone here also. Let me make this one capital M. So yeah, this is fine now. Now let me give Control J here. Let me give clear screen. Yep. So let me type Python followed by the file name dot py. Yeah. So here we are getting the output bid accepted Alice, bid accepted Bob, auction already ended, winner Bob with a bid 600. See here. Let me explain you what we have done actually. See here within the this one example usage or the demo usage. First we are creating the a singleton or single auction manager instance, right? So this is the main class. Yep. So this is fine, I believe. Then we are creating an auction for the laptop starting at 500. 500, let's consider this one in the rupee actually, right? So re- we have created an auction for the laptop starting at the 500 rupees, lasting 5 seconds only, right? Auction equals we have create I mean we are calling create auction method here. So this one A1 laptop as well as this one 500 rupees 5 seconds. Yeah. Alice places a bid of this one 550. So this has to be more than 500, right? So Alice places a bid of 550. Yeah, this is fine. Accepted because it's more than the current price. Yeah. Next, Bob places higher bid of 600. So higher place of higher this one higher bid of 600. Alice has placed the bid of 550. The next this one Bob has placed the bid of highest bid of 600 actually. Both are accepted. So we will wait 6 seconds so that auction completes. The maximum is 6 seconds we have kept here, right? So this is fine. So Charlie attempts a bid after auction end, right? So after 6 seconds, auction will be ended and we cannot place a bid, right? So this will be quite obviously it will be rejected. Charlie attempts a bid after auction end, right? So this should be obviously rejected here in this case, right? So see whether the price may be high, no doubt, but the time has ended, right? So after the time has this one time got ended actually, no one can place the bid, right? Within the 6 seconds actually one has to place the bid. Yeah. Now Charlie's attempt will be rejected actually. At the end what we are doing, we are printing the final winner. Alice has placed the bid of 500 and Bob has placed the bid of 600, right? Alice has placed the bid of 550 rupees and Bob has placed the bid of 600 rupees. Yeah. So Bob has placed the highest bid and Bob will be considered here in this case. Yeah. See here, bid accepted Alice initially 550 rupees, bid accepted this one Bob, this one initially 600 rupees, and Bob has placed the highest bid of 600 rupees here. So auction already ended and winner will be Bob, right? So see here, Bob with the bid 600. Yeah, Bob with the bid. Suppose if we consider this one as rupees, Bob with the bid 600 rupees, right? So we have got the correct output, absolute correct output for the code that we have written. So whatever the code that we have written works absolutely fine, right? So we have got the desired output. So now we have completely discussed the code that we have written. We have completely discussed the output part as well. We have got the desired output. Next, it's the good time to move forward. Let's discuss the limitations for the code that we have written. So here the first limitation is no persistence. Yeah, no persistence in the sense we are not making use of any external database here, right? So we are just considering in memory here, right? So we are just going with the in memory as we are dealing with single file CLI demo, right? So this is one of the limitation actually, no persistence, right? So all the data will be lost when the program stops actually. This one we have to keep in mind. So this is one of the limitation. The second one, scaling to thousands of users is not feasible with the in-memory state. We have to make use of external database, right? So we can just go with the SQLite. We can just go with the NoSQL, SQL, anything, right? So, but scaling to thousands of users is not feasible with an with in-memory state actually. Third one, so this is one of the limitation. The third one, no authentication or user identity verification. Yeah, we are not going with authentication or the user identity verification, right? We are just going with a simple code, or we just went with a simple code actually. This is fine. This is also one of the limitation. The fourth one here would be no support for the multiple bidding strategies. Yeah, as for this one, for example, proxy bidding, right? So we're not going with a proxy bidding and other stuff, right? So no support for the multiple bidding strategies. The final one here would be no real-time event streaming to the clients. We are not going or we are not providing real-time event streaming to the client. So this is one of the limitations as well, right? So these are some of the limitations that I wanted to discuss actually. I wanted to discuss. Now we have successfully discussed the limitations of the current code. It's better to move on with the further things, right? So we have come to the ending part, nothing but this one. What do we call? Mm, Alternative algorithms and the trade-off, right? So let me explain this one directly. So here in this case, alternative algorithms, the first one we can just go with this one. What do we call? Balanced BST or the max heap, right? So we can just go with the balanced or this one, max heap actually. Yeah. So yeah, we can just go with here balanced BST or the binary search tree or max heap, right? So here we can make use of the balanced BST or the max heap. The main pros are here. This one, faster retrieval is possible. Faster retrieval of the historical max bits is possible, and the con here is more complex to maintain. Thus, we have to consider, right? We can just go with the balanced BST or the max heap. Second one, we can just implement event-driven architecture, right? You can just implement here event-driven architecture, right? So this is fine as well. So the main pro, the advantages, we'll be going with the real-time updates. We'll be receiving real-time updates, and it is completely scalable. And the con here is it requires infra like Redis or Kafka, right? Redis, cache or Kafka, right? Message queue, right? So this is fine. The next one is we can just go with a persistent database. Yeah, we can just go with a persistent database. Yeah, here the main pro is when I say persistent database, we can just go with the SQL or the NoSQL database, right? So the main advantage here would be data durability as well as the analytics, right? The main cons here, it is more complex and reduced simplicity. Yeah, whenever we are implementing persistent database. The final one, we can just move on with a distributed this one locking mechanisms. We can just move on with a distributed this one. What do we call? Locking mechanisms, right? So we can do that as well. We can go with distributed locking mechanisms, right? The main advantage here is safe bidding across multiple servers, and the main con or the disadvantage here is latency. We have to deal with the latency as well as the operational overhead. So these are some of the alternative algorithms that we can make use of, right? Along with the trade-offs, actually we have discussed the trade-off as well. Balanced BST or maxip, event driven architecture like Redis or this one Kafka, nothing but Redis caching, this one Kafka, this one what do we call messaging queue actually. Persistent DB, we can go with the NoSQL or the SQL. The final one is distributed locking mechanisms, right? Yep. So we have successfully designed this one. What do we call? We have successfully designed auction system or the online bidding system, right? So next we will be designing inventory management, right? So for now, whatever we have discussed, I hope whatever we have discussed is completely clear along with the coding part and the this one, what do we call UML diagram, right? So for now, this is it. Thanks for watching, guys.